Teradata Loom provides data management for the Hadoop data lake. It enables users to more easily find, understand, and prepare data in a Hadoop cluster. Loom includes a framework called ActiveScan, which automates many aspects of metadata and data management. ActiveScan constantly catalogs and profiles data in HDFS and Hive, automatically discovering new data and registering it with Loom, and doing some profiling to generate technical metadata about it. As a user, I can come here to the Loom workbench, which is the user interface, log in, and come to the sources section, and this is where I will find everything that's been cataloged by ActiveScan. I can sort and filter to find what I'm looking for. We can see here it's a mix of binary and text files in HDFS, some relational databases for the purposes of tracking data lineage as data is being imported and exported from the cluster, as well as some Hive databases. So if you are registering your data directly in Hive, ActiveScan will find that and it will pull out whatever metadata is available from the Hive metastore. If I drill into a source here, I can see a summary with some descriptive metadata, some provenance about how this entity was created and when, as well as how often it's been used, when it was last used, and some related entities. Then I can see some technical metadata. In this case, we're looking at a source that represents a directory in HDFS that contains delimited text files, and I can see below that this means a single CSV file in this case. And if I flip to the Tables tab, I can see details about this file, including a preview of the data, which is driven by a sample that ActiveScan generates when it first finds this file. So here we're looking at the first 1,000 rows, laid out into a nice table with a schema along the top that again has been automatically generated by ActiveScan based on the contents of the file. If I flip to the schema tab here, I can see more detailed information about the schema, and this is where I can also start to add my own metadata. So if I want to describe individual columns or tag them, set custom properties which are configurable for your particular installation of Loom, I can do that here on the schema tab. I can also come down to the overview tab, and I have the same functionality at the table level. So I can have a description for the table, tags for the table, and again, custom properties. And here I can also make relationships to business glossary terms. So here I see the books table here has been mapped to the concept of a work and the concept of an author. If I wanted to make another mapping, I just click Add, come in here, browse for the available terms, choose a term, and then hit OK. If I want to navigate to the page for one of these terms to see other data that's related to the same concept, this is a clickable link, and you'll notice as I'm going through here, all throughout the product, anytime you see a relationship to another entity from one entity, that will be a clickable link that you can use to navigate to see more details. So here we're looking at the concept of a work. I can see the definition, a status. I can see related glossary terms, so other terms that are related to this term, and then I can see technical entities that are related to this term. So ActiveScan is out there cataloging and profiling the data, generating a lot of the technical metadata. Users can then come in, drill in, and see details about a source, and then start to add their own metadata, descriptions and tags and custom properties, as well as business glossary terms, which gets a little more formal. All of this drives understanding of the data. So when an analyst or a data steward comes in to look at some data, they can understand it better, and it also drives data discovery. So if I'm interested in publishing, I can come to the publishing glossary, look at these terms, drill into a term, and quickly get links to individual data elements. All of this metadata is also indexed for search. So if I want to just run a keyword search, I can come over here and run a search, and that'll go over file names, table names, column names, everything else we've been talking about, business glossary terms, relationships. So all of this is about helping people find and understand the data, giving them a way to add their own metadata. As we move from sources to data sets, this is where we're getting more structured. We're moving the data from HDFS into Hive, if it's not already in Hive, putting a schema on it, doing some data profiling to generate statistics. So we see a row count, At the column level, then we have count of null and empties, minimum and maximum length for strings, minimum, maximum, mean, and standard deviation for any numeric columns. And then I also have this use and transform button. So this is where I can go from just data discovery, data understanding, adding metadata and descriptive information to actually executing transformations. So I have the option to run a Hive query, which is very basic. I just come in here, write whatever Hive QL I want to, and then Hive will execute that. Loom will track all the metadata associated with that. Or I can launch Weaver, which is more of a data wrangling tool. It's designed to be interactive and iterative and enable you to define complex transformations against a single table without having to write code. So when you load up Weaver, you give your session a name, whatever other metadata you want, and this will be a saved and reusable entity that you can share with other users, you can reuse, you can even automate, so that as new files are flowing in, they can automatically be cleaned or transformed by Weaver. Once you name your session, you see your data preview here, and then along the top you have a number of drop downs that show you all the built-in operations that are available. So for text, you can do things like cleaning white space, or cleaning unprintable characters, or splitting a column part, or doing a substitution. So if you're dealing with addresses and you want them all to be consistent, you can start to go in and break out those individual pieces and replace them with what you want. You can also do schema level manipulation, so if you want to rename columns, even if you want to delete columns, change data types, those are the kinds of functions that are available. And within Weaver, you're going to be working with this same 1,000 record sample that ActiveScan originally generated that we're using to drive the data preview here to give you an interactive experience. So for example, if I want to delete the 3 columns at the end here, I click on a column, choose the operation, I get some suggestions over here based on the metadata we know about the column. And then once I have these configured, I click apply, and this is where Weaver's going to run these operations just against the sample. So even though this might be a 270 million or billion row table, I can get real-time, immediate visual feedback about what my data now looks like. So that's just very simple. Deleting a column. Here I'm going to convert a column to lowercase. Same thing. You choose the operation, you configure it, you run it. It goes against the sample, and you get to see what the results look like. Here I'll do something a little more involved. I'm going to use the substring function to pull out the first character of the ISBN code and put that into a new column called ISBN lang. The first character there is an indicator of the language the book is written in. So now I have one column that contains my identifier, the ISBN code, and a new column that contains that discrete value, the code that I'm interested, that identifies the language of the book. Then I can come down here and create a filter based upon that new code column that I've generated. In this case, I'm going to look for everything that is not written in English, which corresponds to everything that's not a 1 or a 0 in my code column here. Then I have a function called delete rows, which does exactly what it sounds. It's going to just delete all the rows in the current table, which in this case means only the ones that match this filter. So I click delete, all those go away, clear my filter and refresh, and we'll see the original table come back. As I've been going along, each step you see shows up over here on the right in my script column. Each one has a little X and a pencil, so I can always go back and delete or edit a step later. Even if I just save this and go away and come back a day later, I can pick up right where I left off and keep iterating until the table really looks the way I want it to look. And again, I have the visual here, so I know if I were to submit this script, I know what the results are going to look like. Whenever I am ready to do that, to take this script and run it over the complete input table, which in this case is 270,000 rows, but like I said, could be 270 million or billion, it doesn't really matter to us. When you hit this submit button, you're going to type the name of the output that you want to generate, and then when you click go, we're going to take this complete step script, whether it's 4 functions as I've shown here, or 10 or 20 or 50. We're going to take that script, compile it down to MapReduce, execute it in the cluster, produce a complete result set, and then, as I said earlier, we're going to track all the metadata about that. So then if I go look at a data set where I've run some transformations before, and we look at the lineage, we get a real clear picture of what's been done to that data. So this is the table I clicked on. You can see, if you trace all the way back to the beginning, we started with a pair of HDFS files. We moved those into Hive, ran those through a Weaver session right here. That produces a clean version of my books table. And then we used Hive to do a join with the ratings table. And I can see the text of that query down there, so I can really get a detailed understanding of exactly how that join was performed and any other transformations that were done along the way. That produces my clean joined data, which in our terminology, that's my prepared data. That's now ready for analysis. The data is in Hive, so if you want to get at that data from an analytic framework within Hadoop, that's going to be very simple, whether that's MapReduce or Pig or Hive. All those have interfaces to work with data in Hive, or outside of Hadoop. Hive exposes data through JDBC and ODBC. It also has its HCatalog API. Loom itself also has an API, so if you want to get more metadata about the table or just get a sample, you can go through Loom's API. At this point, your prepared data is going to be very accessible, very easy to work with from whatever analytic framework you want to use. In this case, you can see the data was actually moved again. So once we prepared the data, we used Scoop to export it out to a relational database where the final analysis would take place. And this is a step that Loom will automatically track this lineage. So all these other steps were executed through the workbench here. So Loom is very much in the loop there. It tracks each operation as the user is doing it. Scoop, though, that's executed outside of Loom. So any user of your Hadoop cluster can run Scoop, move data. If Loom sees that, Loom's going to scan for those operations. If it sees that, it's going to generate this lineage metadata and track those operations and all the metadata associated. So in summary, Loom provides a level of data management for a Hadoop data lake, really helping users to more easily find data, understand data, and prepare data so that they can analyze it farther down the pipeline.